over to you, Matt. Okay, so hello everyone, I'm Matt. I've been a sound engineer for over 30 years, since 1993. I've been making TV ads and recording voiceovers. I'm also a musician. I compose music for TV. Also playing a band around here. So if you're not doing anything on Saturday and you like live band karaoke, come down to Justine's. The winner is playing. We've got a menu of 100 songs. You can come and sing with us. So today I'm going to talk about music in numbers. Music in numbers. Mathematical reasons why music works and how it fits together. So, are we all musicians here?
No. Kind of. Yeah.
I mean, we all listen to music, and you must sometimes wonder, like, how it fits together, why some notes work with other notes, and why some notes don't. So, do we know what an octave is?
Yes.
Okay. All right. So, an octave is basically it's the same note. I'm going to play on a keyboard here. Pretty much, it's the same note, but one is higher than the other. And yeah, many octaves across the keyboard. But that relationship that's an octave. So that was the note A that I was playing. Now, in Western music, between the two notes of an octave, there are another 11 notes. So we'll start with the A. That's the A. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we've reached the octave. So there is there's an incremental increase from one note to the next. Each of those 12 steps reaches the next note in the climbing up those 12 points to reach a note that's an octave above. We go through 12 steps, and they are called semitones. Now, each one of those semitone steps gets higher by pitch, and it's the same percentage for each step. I've written all of this down, so I'm going to just read out my notes here. We're going to get done for you. So each one of these semitone steps, as the pitch gets higher, is a percentage increase on the previous notes, which we'll call P, and it's this percentage change that we want to calculate. So what we're going to do, we're just going to have a look at each of these notes here, and the number of the semitone increases for each note. There goes A to A sharp, B, C, C sharp, down until it reaches the A at the bottom of the full octave there. And what I've listed on the right-hand side there is the names of the intervals between the notes. Now, A4, we're going to use A because it's got the perfect numbers really. The A4 note works at a frequency of 440 hertz. And the A5 note that you see at the bottom of the table there, that's 1760 hertz. So that's exactly twice the frequency that it's vibrating at. And that's why it sounds like it's the same note, but an octave higher. What we're going to try and work out.
I didn't get the numbers there. You said that A4 was...
Sorry. 440
should be 880.
to 880. Yes. The next one above is 1760. So A4 is 440, and the octave below is 220. The octave below that is 110. So let's just do a calculation. You see here, you see the percentage increase. This is what the number that I've created, the unknown number here is P. Right, so we're going to work out the value of P. This is going to be a bit of a maths lesson.
Yeah, I can't remember. Honestly.
Right, so as we see on the frequencies here, So you've got A4, this is 440, A5 is 880, A6 is 176, A3 is 220, A2 110. That is the number, so the curve, that is the number of cycles per second that will create that note. So any note will, any tone that is created as a sine wave, it means it goes through a wave like this 440 times in a second to create that note. So what I'm going to do, you see actually how it creates a curve. I couldn't work out a way to actually draw a curve on my presentation software here. So it is joined together as a straight line, but you see that is forming a curve. Yeah. Okay, so we're going to work with these numbers, which are the numbers for A4 times by our percentage increase to the power of 12, which will then reach the octave note, which is 880. This will work with any octave, by the way. It would work from 880 to 1760 or 220 to 440. So the first thing we can do with the equation is cancel what's the same on both sides. So we'll just take out the 440 and replace it with 1. And we'll turn the 880 into 2. So we're dividing both sides here by 440. Okay. So that's that simplified written out. P12, P to the power of 12 equals 2. So what we need to work out P is the 12th root of 2. Yeah. Now what you can do work this out on your calculator. Yeah, I'm not going to do this on pen and paper. Right? That is, check it on your phones if you need to, but that is the number. So
it's on the slide, we believe it.
The value of P is 1.0594. So turn this into a percentage. Right, so we're multiplying both sides now by 100. So the 100% of the original note, the next note up, the P percentage increase, is 105.946, and the following numbers of the original note. So it is a 5.946% increase. Okay, so we go to the table here. These are the incremental percentage increases for each note. I've typed that one wrong. That should be 5.946%. Then if you multiply that number by the 5.9, or increase it by 5.943%, we'll get down to the next number, which is 12.246%. And on down the table until you reach the 100%, which is the percentage increase for the A5 note, which is an octave above. This is making sense. So
yeah.
Good. Good. Right. So because this this will keep curving upwards, by the way. So if we were to go and try and work out for A sharp, for instance, what the next note was, the next, sorry, I'll take a step back. I've just put in the frequency values for the two notes that we know already. It's A4 and A5. We now know, using the calculation of the percentage increase, what the percentage increase on that 440 will be to create A sharp, which will be, that is 466.16 hertz, is a 5.946% increase on 440. Then we can create the next calculation, and eventually we can just fill in the whole table there. by using a simple mathematical calculation. Using what's in the first two columns there, as you can see, any octave is, or the relationship between an octave is 100% increase on the lower note. So with the A, it's 440 hertz. With the A at the bottom of the table, it's 880 hertz. We can work out the same for A sharp. So the A sharp there is 466.16, and at the bottom, it's 932.33, which is double. And then we can work out the same for the B. 493.88, 987.77. This is, by the way, using the same incremental, so this works out all of the frequencies of the notes through all of this octave. And the same there for C. That's for C above middle C, 523.25. And the C6 at the bottom is double that. So you just scroll back through these, as you can see, as I'm going from A to A sharp there, the name of the note is changing, the frequency is changing, the semitone increase, the interval name, so the relationship between the root note and all of the other notes in the octave, and also the percentage increase is the same for, it doesn't matter where you start, you use the same numbers and you can get all the way through an octave.
Why do we call middle C C5? Is that just like a convention? Or
Well, we call actually it's called C4. So on the lower note of the piano, it will start on A0.
And is it
A
also
zero.
key? Yeah, I know, but
On an 88.
That's what I mean.
On an 88 key keyboard, yeah.
Okay, so it's just a convention, really.
Yeah.
We say the lowest note is going to be at this frequency, and then go from there.
Yes.
Okay.
Yeah.
But it's just widely adopted.
It's widely adopted, yeah. I mean, and it all fits within the range of human hearing as well. So,
Okay.
you know, humans can sort of generally hear between, they say 20 to 20,000 hertz. So that's, I mean, that reduces off the high end as you get older.
Yeah.
You know, yeah. My hearing of high frequencies isn't what it was. I used to be, when I started sound engineering, I used to be able to hear all kinds of things that I can't hear now at the very high frequencies. Right, so let's go on to, yeah, so as I said, this is the same for all octaves. And this is kind of what's important in terms of how music fits together. So any musicians here will know if you're playing a chord, relationship between two notes, such as, what are we playing here? Right, so the A and the E. Right, so the A to the A is 100%. Look at the A to the E, that's 7 steps up from this original A. 1, 2, 3, 4, 5, 6, 7. They work in harmony. See how they sound good together, much better as a, you know, they sit well together. More than that, I mean, that kind of conflicts, but this works in harmony. The mathematical reason why that happens is if you look at the 7th semitone increase here, you can see that the percentage increase is very, very close to 50% within, you know, it's less than 2/10 of a percentage point. So what that means is the waveforms, they cross over each other. So this would be the perfect prime, which would be the root note. This would be the wave of the octave, the sine wave that I was talking about. Now this perfect fifth slots very nicely into those two. if you see the point where the wave actually crosses the zero amplitude line, it lines up. It's not perfect, it's not absolutely exact, but it's closer than any of the other notes.
So you sort of see a repeating pattern.
It's a repeating pattern,
but they're sort of crossing points.
and this is the harmony. This is, you know, as they meld together, this is the harmony that creates. It's just why it sounds nice together. Again, also in this chart, I've taken away. Let's go back to this. What I showed in this table was the percentage increase, but it's going to be more useful to show the zero that the semitone, the original note, the prime note there. We'll say that was 100% of the original, and the octave is 200% of the original. So it's just showing the relationship. Now, if we now look at what's called the perfect fourth, which is here, it's 5 semitones up. You can see that this value is almost exactly 2/3 of this value, 200%. And this is why they're named the perfect fifth and the perfect fourth, these two intervals. One being so close to 50% and the other one being so close to 2/3 of the note above it. So, and it's actually the same relationship, because if you're 7 notes from the root note, there's only 5 until you get down to the full octave.
When it says fourth, does that mean like a quarter?
No.
It's the fourth.
No, it's the fourth note in the octave. So out of any one of these, there's 13 notes here as an interval between the octaves. And all of those notes appear as, they all exist, but they don't all work in harmony in a scale. So there are lots of these notes in different scales that you would miss out. So if I were to play the scale of C on the piano, it would be basically, it's all the white notes. That's a major scale. Then there's also a minor scale. There's a couple of notes that are changed in there. So these intervals depend, and there are 3 different minor scales. You'll have a yeah. I won't get that far into it, but you can see these intervals are labelled minor second, major second, minor third, major third. The perfect fourth and the perfect fifth, they tend to appear in most scales, most harmonic scales, because they kind of work with everything. So when you're creating a chord, the chord is generally made up of 3 notes. But 2 of those notes will be the root and the perfect fifth, which work in that perfect harmony. Or that, which is the perfect fourth, which also works in perfect harmony. Yeah, so this is the perfect octave as I play the top octave here, which works with that note, which is 2/3 of the value. And so if you look at the full, it's 1.5 cycles there, but you can see it crosses the line 3 times in the perfect octave. The perfect fourth will only cross the line 2 times, but this is how those waves intertwine. Yeah, broken up into thirds there. That's pretty much all I've got to say about the numbers of how music works, really.
Well, thank you. I know
Yeah,
there's going to be lots of questions.
Yeah.
But that's very good. Thank you very much. I dabble with music, playing the ukulele whilst drinking beer, mostly. But people talk about F major diminished 7 or something like that. What are some of the weird things? Completely black magic, weird I don't understand what's going on. But someone said it's something to do with semitones, and I recognise some of the words there in the right hand table. So if you're reading guitar tab or something like
Yeah.
that, and it asks, but an A minor, that seems to be an A with one of the notes down a semitone.
Yeah.
But there's some way complicated mashups of these notes that just completely bamboozle me and throw me off.
Generally,
Are they for people who sell chord books? That's,
so a C major chord, there's a C at the root, it's perfect fifth, which is a G, and a major third in it. Okay, so that plays C major. Okay, the C minor will have the C in the root and the perfect fifth, but it will also have a minor third. So it's the difference between, that's what they taught us in primary school, is a happy chord and a sad chord. There are also other variations of that. So you've probably heard of a C, C with a suspended fourth. Well, that's, instead of having a third in there, it's got. Oh dear.
might need more than.
Yeah, let's stretch it out a bit. So that's a suspended. That's a suspended fourth. Suspended fourth.
So is that still the C
So that
major
is,
with
I'm
an
playing. What I'm playing there is I'm playing the root and the fifth, but it's got that, instead of having a major third, it's got the perfect fourth in there. So just. There's lots of songs that you'll recognise that have got that. If you know A Little Respect by Erasure, it's very difficult to play on a phone. But yeah, that's listed with that same interval, which is the what they call a suspended fourth. So usually, when you were talking about chords like that, and it says that it's got a like a suspended or a. I mean, sometimes you have you might have a C7, for instance, which has a seventh interval in it. So that would be a major chord like that, but with a minor seventh accent.
Which keys is there C7?
C7 will be this one, this one, this one, and then this one.
And what was C major?
C major is just those three: C, E, and G. And a C minor will be a C with an E flat. So that's an E flat. Yeah, D sharp. It's also an E flat.
C minor is a C.
Yeah.
What's the next one?
E flat, or what you put it as D sharp, and a G. So that, and they will fit together.
C major is E, G.
Yes.
Isn't that Erasure song
Yes.
that we just played?
Yes.
Was it because somebody who's just played it that they liked the sound, or did they work out? How was it derived? Is what I'm getting at.
Yeah.
Was it
Well,
derived by
what
what
you
you've
talk
been
about that.
explaining? Best.
So here's what I think about music and composition: is that I have seen, the more I've learned about music, the less creative I've been, the more I've been restricted by rules, until I then learn how to break the rules again. I think some of the most inventive music that ever gets created is by somebody who doesn't know what rules they have to stick.
Right.
They're told to stick to.
Yeah.
You know, and there's a lot of painters like that too.
Yeah.
You know, you tell somebody, right, well, you can't do this. Why not? Sounds fine. You know, it sounds absolutely great.
And that's useful to
You've
know
got to
the
say-
scales to work out,
Yeah.
like as Matt was saying, to work out whether it's an A minor or a major 7 maybe. But who created the set of scales? Was it just musicians and mathematicians coming and playing it, or was it?
Well, I mean, in Western music, that we've sort of settled on an octave which ranges 12 notes for about 300 years. Yeah, well, they did have on the old harpsichords. They did actually have quarter notes as well. But yeah, problem with them is that a lot of the time they just sound very discordant.
Do all
Sound like
cultures
tune.
have the same expression?
No, Indian music can be very different. But a lot of cultures have a very, it's similar, but yeah, there are. I'm not an expert on that. And to answer your question about who decided on this, really, I mean, this is about the maths, and you don't really have to be a musician to work out that this fits together as it does in these, that would fit together. That's a very mathematical way of looking at not just music but just sound, really, and waves in general.
I get that.
Yeah.
And you can do it on a keyboard, okay, that one and that one.
Yes.
But if you've got a stringed instrument,
Yes.
at the same time, you've got to play different strings.
Yes.
Together. So the gap between the strings is important.
It is, and
So are they all fifths between the strings?
no. So I mean, a guitar is tuned so that it's tuned so that the next string up is a perfect fourth interval.
A fourth.
So it's 5 semitones, then 5 semitones, then 5, then 5, then 4. Sorry, 5, 5, 5, then 4, then 5.
1, 4.
Sorry.
Why suddenly 4 in between?
Because so I'm kind of second guessing this really because I mean it's old and things time ago. But it will be around getting the bottom string and the top string matching so that they are both playing in a year. By the way, if any of you play guitar or ever tried to play guitar, you've been told, okay, this shape is a C, this shape is an F, this shape is a what you are doing when you are playing those notes. So on a guitar, for instance, you've got your frets here, which are that. Now you'll be told that that's an open string. You'll play that there. You'll play that there. You'll play that, and then you play those open, and that is an E major chord. Now the reason why that works is so an E major chord here on this piano would be this one, and this one. Okay, so you're playing an E, you're playing a G sharp, and you're playing a slightly. Sorry, yes. So for an E major chord, you're playing an E, you're playing a G sharp, and you're playing a B. Okay. What you're doing here on the guitar, so these strings are E, A. So this one.
I'm just amazed you've got 6 strings. I mean, it's 4.
B, E. Right. So on this string, you're playing an open string here, right? So that you're playing an E there. You're playing an open string there. That's an E. Okay. On the A string here, you're 2 frets down. Okay. So that's 2 semitones. 2 semitones from an A, is a B. Right, on the D string, 2 frets down, that's 2 semitones, that is an E. If you want to check any of this against what I'm doing, say A there, 2 semitones up is a B, 2 semitones up from a D is an E. Okay, this one on the G, that is a G sharp. And this is, we're playing a B there. Okay. Now you'll see that E, B, E, G sharp, B, E. E, G sharp, B. You're playing the same notes that you would be playing on the piano.
It might be important to say as well, going from E to F and B to C is also just a semitone.
In terms of, yes, it is,
Yeah.
yeah. So the on the keyboard, if you go to, it doesn't matter whether it's a black note or a white note,
Just one up.
that's a semitone up. That's a semitone. The intervals there are a semitone as well. The only reason this is laid out in the way that it is because it's, well, this is the convenience of the notes and the way that they are labeled by these, you know, sharp and so on.
Just a Western music thing.
It's just a
what works
convention,
for it.
really. Yeah. And it's the white notes aren't sharps or flats, but yeah, these ones are. But they are just semitone intervals from one note to the next. And that's exactly the same on a fretboard. So that would be your 0. That would be your prime note. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We've already said when you get to 12 here, that's an E, the same as that open string there, isn't it? And that's the same for all of the chord shapes. So if you're doing in the orange pen, if you're doing a C, you wouldn't be playing that note. So that's a C, that's an E. That one's open on this one, so that's a G. Again, that's a C, and that's an E. So you're just playing the notes that you would be playing to play C, E, and G on the piano as well. And that's the same with all chord shapes. And that's why some chord shapes are more difficult to hold than others, because you do have to just get those right notes. But generally, with any chord, you'll be playing either, on a guitar, you'll be playing either 3 or 4 notes on most chords. There are some complicated chords that have 5 notes in them.
When you play that, so this chord,
Yes.
you've got 3 E's, so
Yes.
that gives you a bit of a harmony with the same note but at different levels, or are they the same frequency when you play some guitar?
No, so this is an octave up. This is an octave up from that one, and then this one is an octave up from that one as well.
So is that a form of harmony, playing the same note but at different?
Well, it's an octave. I mean, it harmonises perfectly because it's the same wave. It's just like this chart here. I don't know what's.
Oh, that's me on that computer. Just press the X. So.
Yeah.
Yeah, so that would be giving the perfect prime waveform and the octave, and then an octave above, which would go through, whereas this octave goes through 2 cycles, the next octave above would be going through 4 cycles. And the next octave above that would be going through 8 cycles.
And they sound nice together. Like a
They
quiet
sound, yeah. Well, they're octaves, so it's not creating, you know, what's actually called a harmony, because it is the same note. They work together, but they don't harmonise in the same way that that does, where they interact. They actually, all of these waveforms would add together so that, you know, where you'd have, I'll just try and explain this.
You know, they would beat together.
Sorry,
Like beat frequency.
yeah, I mean,
Yeah.
so
I wondered if that would be.
this crest here would add to that crest and to that rise of the crest there. There would be a point where they would, you know, where they would cancel. And so, for instance, I mean, I have this thing in sound recording which is called phase, where actually, if you flip turn the waveform, so it was in exactly the opposite phase from.
That would cause beating, wouldn't it?
If it's actually
In sync,
perfectly
perfectly.
in resonance with each other,
beating.
they would just cancel.
Yeah.
It would just cancel.
An aircraft does that when it's two engines and they come together in sync.
Yeah.
Yeah.
Yeah. And there's a lot to, I mean, you know, in terms of using microphones, I don't know if anybody here listens to podcasts or makes podcasts or has ever done recording or anything like that. I do training courses in how to make podcasts, use microphones, all of that. But there is a situation where you have a microphone that has like a large response field on the microphone where you can actually hear when you're off mic. Like if you're to the side of the microphone, the higher sound frequencies actually cancel, and that's because if you think of like a flat surface like my hand with a short frequency, a short wavelength frequency, you could very well have the crest of a wave that's coming from sound reaching this side of the edge of the microphone at the same time that a dip in the sound. So what I'm talking about, the crest and the dip, is this would be a crest, this would be a dip. Now, if that and that, because of the way the sound travels through air, at the speed of sound, if they were to hit the responsive part of the microphone at the same time, then they would cancel. So that one side of the diaphragm on the microphone would be pushing at the same time that the other side is pulling, and it would cause there to be no sound created at all, and that's why you lose a lot of high frequencies around the side of a microphone as to when you're sort of directly onto it. That's a whole other area, really.
Metal detectors, they're one frequency alters to a fixed frequency. You find metal.
Okay, yeah.
We've got these things up here, and
Yes.
the left and the right example are both semi-channels between one fret and the next fret, one key and the next key.
Yes.
Right, supposing the third instrument is a saxophone.
Yes.
Has that got enough holes in it that it will play every semitone on the way up?
I don't play the saxophone.
Well, I was going to then exaggerate and say, well, what about a trumpet? It's only got 3 valves. Now, surely, with a combination of 3 valves, it couldn't possibly play all the semitones.
So I know I only know what I've heard from speaking to trumpet players, and this is a skill I couldn't imagine having. The notes on a trumpet are played through the pressure that they blow into the drum. So at the same time as using their fingers, they're also blowing at varying rates and making the brass resonate at a different frequency. And then the buttons are used as fine tuning.
So a C on a trumpet or cornet is open keys, but you can play an octave part by blowing in a different way.
So I guess that's what a bugle players do.
Exactly. Yeah. But with a trumpet, you do have combinations of keys to change the length of the pipe. But you can play an A with pressing the first 2 buttons down. You can play the next octave up.
But you can
pressing the same buttons, but you change the way you blow to go up the octave.
You can play every note in the octave on a trumpet. So there's I mean it's quite complicated to do that. I think a saxophone. I mean, a saxophone's like a bendy clarinet, isn't it? So it's.
I know a saxophone.
I think actually, I mean, I think if you can play the clarinet, you can play the saxophone. I think that is I've heard that. Again, I can't speak with any authority on it. There are some instruments like the mouth organs, the harp, the old blues harps. A harp player will carry around 12 mouth organs in a case.
Seen that.
And That's because they don't play all the notes. They only play either they'll play in C or C sharp or D or, and you can't really go, you know, if you're told what key you're playing in on a mouth organ, and you just kind of put it out, you can just kind of play anything. It all works.
You need to say what a key is.
Yeah,
Sorry,
We haven't said what a key is.
what is a key? That's all it is.
Okay,
Yeah.
all right.
Only.
So,
Or did you have somewhere to go?
okay, so the key of
See,
let's say, should we start with C?
Yeah.
Okay, we'll do C. Right, so the key of C major is all of, I just touched on this earlier, but yes. So a scale of C major is all of these notes: C, D, E, F, G, A, B, and C. Put a couple of notes on the end there. Point. Now, the relationship between these notes is two semitones, one semitone, two, 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 one. And that is the relationship, the same relationship between any set of notes in any scale. So if you start with D, right, this time it's going to be two. So this is D, E, F sharp, G, A, B, C sharp, D. So again, you just kind of pick all of that up, shift it along one. So that's 2, 2, 1, 2, 2, 2, 1. And that's the same in all major scales. And then a minor scale, the best minor scale to show you on the piano, actually, is A. Put these in. Minor scale. If I'll play a minor scale here. So this is
A minor.
Yeah, A minor. Yeah, so C major is the A minor scale. But one sounds more down than the other. You see here the first one. Right, actually they're all the same notes. So it's just the intervals between them. So in that last, the A minor scale I played, it's A, B, C, D, E, F, G, A. It's just that the intervals for a minor scale are 2, 1, 2, 2, 1, 2, 2.
That's really interesting to know that an A minor, I just assumed had a flat in it somehow. So I didn't realise that interval came.
No, so yeah, so C would have an E flat and a B flat in it.
But that's all just down to the interval.
It's just down to the intervals. Those, and it's why so a lot of guitar players, if you're playing guitar, a lot of guitar players will learn the pentatonic scales of, so that they can solo. So if they're playing a song that's in G, for instance, they will actually do their solo around the E minor pentatonic, because that's 3 semitones down. So from the C major, 1, 2, 3, down to A minor, that's the scale they've learned, is the A minor scale, so that they can do their soloing, but it does correlate to C major. So it's a correlating minor scale to the major scale.
You say
Yes,
that music can be written in different scales,
yes,
different keys,
yes,
but on the keyboard,
Yeah.
all of the notes are accessible. You just hit with your finger a note, so
Yeah.
you could actually play anything, depending. It wouldn't really matter what key it was written in.
Yeah.
You could still play those notes. It just that it would be displayed differently on the score.
yeah. I mean, Matt actually called these notes up here. He's labelled them all as sharps. Now I would like, this is D sharp here. I would call that E flat because it appears in more scales as an E flat. And the same here. This is also a B flat. In fact, all of these notes they also have a correlating flat note. So you could be playing this note in one tune that you're playing, and it will be scored as because it's got, you've got your scale at the beginning, and then it might draw in there. There's a, it might have a flat there, but in another piece of music, in another key, they wouldn't put that. They would put a sharp on that line, but it actually correlates to the same note. So
So whatever key written in,
whatever key
you're
it's
still
written in is
hitting,
what you play. Yeah.
still hitting particular notes.
Yeah. Yeah. So you can determine from the sharps and flats at the beginning of a musical score, because what they don't do, they wouldn't, if you wrote something in C sharp, it would be C sharp, D sharp, F sharp, G sharp, A sharp, C, C sharp. Piece of music is written out as on a stave. It's just going to look a mess if it's got sharps written all over, for every single note. So that's why they do this, the key signature at the beginning of a piece of music. And then when there's a key change in the middle of the piece of music, you'll see that the sharps might change for flats, as the key changes. But again, you have to be quite an accomplished musician to be able to read that. I don't sight read music. I play by ear, and I play by being able to listen, and I compose. But I compose on computer software where I actually play the instruments and work out what the notes are. So it's a bit like the difference between being able to speak English and write English, and read it.
If there's some piece of music in the key of C,
Yes.
the melody would, did you say you would use the A minor range of notes, or is it the CD?
Well, the notes are the
They're
same.
the same note.
They're the same notes.
So that's the melody that someone might play with a solo, but there's like a series of chords that
Yes.
go with that, and that's where those what you're saying during the presentation bit, where it would be the root notes and the perfect
fifth.
perfect fifth.
Yeah.
But what would be the third note of a chord?
So in the scale in C, okay, you would have 3 major chords. It could be C major, F major, and D major. Sounds like the beginning of sounds like incidental music for the in-betweeners. I'm sorry, G major. That's G major, yeah. But then you'd also have D minor, E minor, and A minor, which is there. And most songs are constructed around a variation. I mean, you could play you could play a C, an F, a G, it's an E flat. But that sounds quite nice, you know, but it's not part of the scale. It just sounds nice, doesn't it? But yeah, okay, so like a rolling stone, yeah. There's an escalation through C, D minor, E minor, S,
So the
G.
choice between the three.
Yeah. And then it didn't go as fast as in an A minor. I don't think it would have worked. Yeah, so that all works within the scale. So that's the maths of it, but that's the basic, very basic maths of it. But like, you know, like I say, that E flat, that that chord will work in there as well. It actually takes you somewhere else, you know, and it will work harmonically. It does fit together with the music.
I remember getting sort of hung up on like whether it's a D sharp or an E flat, and trying to understand why that was the case. And I thought when you sort of listed out the notes of a key, you almost wanted one of every letter. So and so to figure out if that is correct or not, you have to tell me. So if I wanted to do a C sharp major,
Yes.
I'll go C sharp, D sharp, E sharp, F.
For a chord?
No, just to list the notes of the scale of the key.
C sharp, D sharp.
And then I'll call it E sharp.
Which is an F.
Yeah, that's right. That means, and then I've got F.
You would call it an E sharp because when you're writing your key thing, you'd have to put a sharp on the line E. So
Yeah.
you then get 6 sharps at the beginning.
You would,
But I mean, I mean that gets done.
Yeah, C sharp would be written like that.
Yeah.
It says as a violin player years ago.
Yeah.
so it's interesting then that there are so many different names that can be given to a physical note. It just depends in the context of which key you're in. And the key is almost like
Absolutely, yeah.
a key is just a sort of a way of explaining what you've invented.
Yeah.
Okay.
I mean, in fact, yeah, they do put 6 sharps on when they do the scale of D sharp.
Well,
Yeah. Yeah.
and so the chords, the progression C, F, G, that pops up all over the place. So is there something sort of interesting about why they keep popping up and why they always work together, you know?
Is that to do with the scale as well?
Yeah,
I mean,
because
it is.
they're all in
It's well, they're all major. They're all major.
Cool.
There are 3 major chords that will appear in the scale in the key of C.
And the root which has got that relationship you were talking about earlier, like where the fourth is 2/3.
Well, so the root note is the perfect 4th.
Yeah.
But so you know the notes in C would be C, E, and G. That would be a C chord.
Yeah.
Right. An F chord would be C, F, A, and C. Right. So it's F, A, C. Easier to say like that. But as a keyboard player, you would play it like that. Right. And then the G, go back to the C, and then the G would just be that. Okay, so that's C, B, and D. Right, I'm playing it like that. C, B, G, B, D. G, B, D. Okay. Yeah, so there's a perfect 5th there, you've got a perfect 5th there. Right, it just, I mean, it sounds, as your majors, the relationship between the root note and this G was 50%.
Yeah.
As we said. And the root between those two, the relationship between those two is, well,
Is it the third?
it was that's the one that was a third, yeah, where this one is 2/3 of that. that's sort of half as much again. No, not half, no, that's a third as much again. Yeah, so 33% more and 50% more. So they fit mathematically. And then, you know, all of those notes in between. Yeah, so also looking at, you know, what we're talking about there is the major third. That's almost, it's as close as you get to 25%. You know, and the minor third is as close as you get to 20%. They're all very closely linked in terms of the waveforms are going to fit over. It's like the longest of the waveforms are going to fit over that root note and the perfect fifth, as well as any other notes can. So they will be crossing that zero line more frequently and closer to the harmony of those roots and perfect fifth notes.
So you called this a harmonic scale, but yeah. It's, what other scales are there?
Oh, so well, I describe it as a harmonic scale. Well, I mean, it's the harmony because it's the waveform. So
Is this what I mean by constant pitch? Because isn't there some other sort of tuning you can get? And but people go, oh, every constant pitch now, and I wondered if it's that even.
So I think that
those
relates
even
to. So there is there's okay. So I'm trying to remember constant pitch.
So
There's an
that's
argument
not-
as to whether A should be 440 hertz or whether it should be 432 hertz.
Okay.
Sounds a little bit
I seem to recall when I was playing in an orchestra, they used to have a concert pitch, and I think it was slightly lower. And I think it was to
Very
do
slightly
with-
lower.
I think it was to do with instruments warming up when they were playing, and I think
Right.
woodwinds, always the woodwinds, causing trouble.
So it's not
They brought up and they couldn't then lower them, so they make themselves sort of raising, but they can stretch them, can't they? Make them longer, so they make them lower, but they can't make them higher.
Right.
So they have to start off so they can adjust later as it warms up.
Right.
Whereas the violins, you can move it either way, you're not bothered where you start,
There's no frets.
just wind them up.
So constant pitch is all about that initial frequency and picking like that is the reference point. Yeah, everything else is derived from. Okay. So not to do with the steps.
I'm going to default to my man. I mean, I know more about the waves and the sound and all of that in this particular aspect of music. Yes, sorry.
Well, concentration. Is it a fifth of a tone difference between constant pitch and standard pitch?
So from memory, you might be able to put it right. But I think that they would always tune to an A.
I've only never done it, I've never don't know understand it.
I think I know that there is a focus whether an A should be 440 hertz or 432 hertz.
How long's that been going on for?
Hundreds of centuries. There is an argument that it's, you know, it is probably the practical reason, I would say. There's also, I think there is like the sort of philosophical arguments that for 432 hertz and deriving everything from that pitch is more in harmony with the universe. It's something I've heard and haven't looked into.
It's deep.
Very deep. Yeah, it's tiny, it's minuscule. So it is. Well, we can work it out. So that's the A sharp there is 26 hertz above the A. 432 will be 8 hertz down. So it's about a quarter of a semitone.
So you'd hear it.
Between a third and a quarter.
So if you've got two people tuned differently, you're going to hear it. They're going to sound out of tune.
Yes.
I do have a waveform generator in there somewhere, and an amplifier and a little speaker. So if anyone's feeling a little bit practical, maybe we can experience.
But it is, I mean, it's the slightest turn of a pin on a guitar.
Yeah.
It's, you know, it's minuscule in there, but yeah, you would hear it. But these are the frequencies that, you know, if you have a tuner, a guitar tuner, these are the frequencies that they default to. Yeah.
Any other questions for Matt about music and the maths behind it?
Difference between harmonic and chromatic.
That's a musician question, really, isn't it?
I thought it was a mathematical question.
See. In terms of scales,
So chromatic normally, it's like diatonic, it's one key. It's chromatic, being a key. It's a Gavin instrument that's
One sound, I want to answer. One sounds shiny.
let me just do. Go and get.
But I don't know what's meant by harmonic then in that context. So maybe chromatic needs something else in there. In a different discussion. I'm not sure.
Maybe whilst Matt's looking that up, we can congratulate him on getting a very difficult subject.
Yeah.
Really good.
Okay, so a melodic chromatic scale may be written in a set form. The set form means that the scale is written using a set pattern of notes. In a harmonic chromatic scale, the set form is that the tonic, dominant, and upper tonic notes are only written once.
Got it.
All other notes are written twice.
Yeah.
What was before the difference between speaking English and writing English? Now is speaking English and speaking German.
So the word chromatic is used in both of these. And that means
I'll work it out for next time.
All right.
yeah.
That's really cool, really good. Yeah, that has answered many of the questions I've had in my head. I think.
Okay, good.
Like these intervals and that's the difference between major and minor. Useful, I think. Feels like I'm a sort of country mile away from being a musician that can do things like transpose a key by moving the notes up and using capos and all that kind of. Musician kind of.
Oh, that's it. I mean,
based
you
on
know,
capos.
again, so you know, like here, like where you have percentage increase here, this is all that this is doing. If you put a capo on the guitar, it's just moving all of your chords further down. You know, so if you were playing an A on your scale here, and then you put a capo there, to just play a G, then you'll get exactly the same note. You know, it's a G shape.
So it means if you were singing and you found that you were struggling with the pitch bit, you could just stick a capo on and then just sing. The music will come up to you.
Where'd you pop that capo on?
But ASAP. But it usually comes with the same shapes, isn't it? I think.
Yeah.
So you don't have to think too much. It's that poor saxophone player who's got no chance.